kids. Today we're going to talk about topic 1.8, evaluating algebraic expressions. If we're watching the video as a class, you'll want to take notes, and if you're watching the video independently, you'll want to take notes also. Let's begin. Okay, if you open your book to the lesson, you'll find that this is all about evaluating algebraic expressions. And it asks you, how can you evaluate an algebraic expression? Basically what we mean when we talk about evaluating an algebraic expression, it means that we're solving it. We're figuring out the answer to it. And in this case, they give us an example problem, and they say Willie has one large case which holds 20 miniature race cars. He also has 3 smaller cases with miniature race cars. Okay, so he has the large case that holds 20 cars and the 3 smaller cases which hold miniature racers as well. And if we look closely, we'll see that each one of those holds 14 cars. Okay? The number of miniature cars Willie has can be expressed as 20 plus 3 times x. And the x in this case would be the value of the smaller cases, which is 14 cars. And then they ask you, they say, how many miniature cars does he have if each smaller case holds 14 cars? Which we have concluded. Okay? So right now, we're either going to pause the video for you to answer the Nearpod question, or we're going to move on. If you've been assigned the Nearpod activity, you will answer this question now and submit it. Alrighty, let's move on and see how we evaluate this expression. Okay, our expression that explains how many cars Willie has is 20 plus 3x. The 3x represents 3 cases, okay, of cars, and the x is how many cars are in each case, which would be, in this case, 14 cars, okay? Evaluate means to find a value of an expression. To evaluate an algebraic expression, use substitution. Substitution means you want to replace the variable with a number. In this case, the variable is x, and we are replacing it with the number 14 because that's how many cars are in those smaller cases. If x equals the number of miniature cars in each smaller case, then evaluate for x. Now notice how they say evaluate for x equals 14. That means that they're talking about the value of x is 14. So in this case, you can see we have 20 from the larger case, and then 3 times 14 for the smaller cases, which gives us 42. So then we say, okay, well now we have our 20 in our large case, our 3 smaller cases equal 42, 20 plus 42 equals 62. So Willie has 62 miniature race cars. Alright, let's answer Nearpod question 2 if you've been assigned Nearpod. Alright, we will discuss the answer. Let's move on to Nearpod question 3 if you've been assigned Nearpod. If you're at home, obviously you won't be able to interact with the Nearpod assignment. So then we move on in the lesson and we have a new situation. Suppose that the smaller cases each hold 10 miniature cars. How many cars would he have then? Well, in this case, we're going to use substitution again, and this time the x okay, in our expression will equal 10. So now we will substitute x with the value of 10. So we know that we have 20 cars, and then 3 times 10 equals 30. So then we add 20 plus the 30, and that would equal 50. And so our evaluated expression tells us that we have 50 cars. You can sometimes set up a table to explain expressions, okay? And in this case, you can see the value of x. If it were 14 cars, you would get 62 total, because our expression is over here in the y column. So you have your 10 cars, perhaps, for the value of x, and then you would bring it over here and you would plug 10 in there, and you would have 3 times 10 is 30 plus 20 is 50. Okay? And so the table allows you to give x different values. So x equals 14, then you would plug 14 in here. If you decided that x was going to equal 10, then you would plug 10 in here, and you would get this answer. Okay? So it would come over to there. And that's how these tables work with expressions in there. Alright, let's move on to the next set of problems that we're going to do to review. Alright, and I have a problem. Okay, let's take a look at some of these practice problems. First, in 1 through 3, they want you to apply the substitutions and evaluate. Okay, so each one of these expressions comes with a value for the variable. Okay, our first problem, number 1, if you look at it, we have 7x minus 4. And the value of x equals 9. So in this case, all we do is substitute the value of the x in the expression and then complete the expression using the order of operations. So our expression is actually 7 times the value of x, which is 9, minus 4. Okay? So if you look at that, you have 7 times 9 is 63. 63 minus 4 equals 59. So our answer is, of course, 7 is a coefficient. When we replace the value of x, the variable, it becomes 9. And you can see what our expression would look like if we set it up using the value of x. Alright, let's take a look at number 2, problem number 2. If you look at problem number 2, you'll see that we have 3d, 3 times d, 3 is the coefficient, plus 5 in parentheses minus d, and d has a value of 4. Okay? So in this case, we simply rewrite our expression using the value of 4. So we would have 3 times the value of d, which is 4, plus 5 minus the value of d, which is 4. And now we can solve and evaluate our expression. So in this case, you would see that we have the order of operations must apply. So the first thing we will do is solve within parentheses. 5 take away 4 is 1. 3 times 4 is 12. 12 plus 1 equals 13. And so when we go for our answer here, you can see how it would look if we had it set up and we just did the computation in our head. Alright? Okay, so that's how you solve those problems. Alright? We'll leave number 3 for you to think and work out. Let's take a look at some other ones that get a little more complicated. In this case, they want you to evaluate each expression for 2 6, and 8. So you're going to have three problems to do for each expression. Okay? Let's take a look at number 4. Okay? Number 4 gives us 5x. So 5 is the coefficient of x. And so what we see up here is we have 2, 6, and 8, which will all represent a value of x. Okay? So you're going to do 5 times x when x is the value of 2. You're going to do 5 times x when x is the value of 6. You're going to do 5 times 2 when x is the value of 8. You can, of course, do these in your head because, well, in this case, 5 times 2 equals 10. And so there is our answer. And then in the next scenario, we see that we have 5 times 6, which equals 30. So you uncover it, you can see the value of 30. And then, of course, you would then be able to figure out what 5 times 8 is, and you would get your answer. Okay? So let's take a look at one or two of the other example problems and see if you can solve them. How about if you try solving problem number 5? Pause the video and see if you can solve all of those for the values of 2, 6, and 8. All right, here we go. Number 5, we have x plus 12. Well, we know that we have to use the value of x when it's 2. We have to use the value of x when it's 6. We have to use the value of x when it's 8. So we have the following problems. We have 2 plus 12 gives us that answer. We have 6 plus 12, and that would give us that answer. We have 8 plus 12, and that would give us that answer. Okay? And so if we looked, we'd see this answer, of course, should then be 14. This answer, of course, then you would know what it would be, you would know what it would be, and you would know what this would be. Okay? All right. Let's take a look at number 7. See if you can solve number 7 on your own. Pause the video and give it a try. Here we go. 7, we have our initial expression of x to the second power minus x. Now remember, x is going to have a value of 2. Then we're going to try x with a value of 6. Then we're going to use x with a value of 8. This looks like it could be a little bit tricky, but if you set it up, taking your time, you'll see that we just simply have a new expression which would be written as this. 2 to the second power minus 2, because we're replacing x with a value of 2. And then we simply know that 2 to the second power is 2 times 2, so we would do that first and then subtract 2. So we have 2 to the second is 4. 4 minus 2 leaves us with 2. And you can see how we've come up with our first answer. All right? That's if we use a value of 2. If we want to try it with a value of 6, again, we would just simply have 6 to the second power minus 6. And we know that 6 to the second power is 6 times 6. So this is nothing more than 6 times 6. So when we evaluate the exponent, we know we have 36 minus 6. And if you check it, you can see what the answer is. All right? And so we'll let you solve the last one as far as that expression goes. All right? So there you go, some examples. Now, let's take a look at the table here. In this case, we have a table, and we see that the value of h is given to us in 5 different values. So we have it a value of 6, we have it as a value of 18, we have it as a value of 24, a value of 42, and a value of 54. So in order to figure out these boxes, all you have to do is take the value of h and substitute it wherever you have it. Okay? So let's take a look at some of these problems. I'll clean that up for you. And let's do, for the value of 6, let's give h a value of 6. Okay, so our expression is h minus 6 plus h divided by 6. Okay, now this is going to get a little confusing possibly because there's so many 6's, but let's just rewrite the expression using h with a value of 6. So h, we would have 6 minus 6 plus 6 divided by 6. Now in this case, you're going to need to do the order of operations, so we do what's in parentheses first. So 6 minus 6 leaves us with 0. 0 plus 6 divided by 6 is what we have now. Well, we can't do the addition, we have to do division next. 6 divided by 6 is 1, so now we have 0 plus 1, which leaves us with a value of 1. Okay? Let's try another example from our table. Okay? Let's make it a little bit more complicated. Let's go and we will do 18. Okay? So we're going to rewrite our expression, and we're going to give h, this time, a value of 18. So we have 18 minus 6 plus 18 divided by 6. Following the order of operations, we do what's in parentheses first. And so now we have 18 minus 6 is 12 plus 18. Now we've got to do the division. 18 divided by 6 is 3. 12 plus 3 is 15. So you can see we should uncover a 15 there. All right? So what we will do is we will let you finish the rest of this table on your own. Okay? Give it a try and see how you do. Let's take a look at this word problem. The table shows how much Ty charges for pet sitting. Write an expression to show how much Ty will earn for sitting 2 dogs for a day, 2 cats per hour. Then solve for sitting 2 dogs for the day and 1 cat for 6 hours. Okay? So anyways, here we go. In order to write the expression, you have to understand what you're dealing with. Okay? And in this case, you are dealing with the 2 dogs per day and 2 cats per day rates. Alright? And so what we have here is we have 25, which will be the sitting the dogs, the 2 dogs for the day, and you're going to get 6 hours for sitting, you're going to get $6 per hour for sitting the cats. Okay? So here our expression is you have $25 a day for the 2 dogs plus sitting the cats. So the 25 is for dogs, and the 6x is for the cats. Okay? So now all you have to do is figure out how many hours you'll be sitting for the cats and how many cats you'll be sitting in. So the value would be 61. Okay? Alrighty. Let's take a look at this expression. In this case, they want you to evaluate the expression 6 plus 8f for f equals 4. So again, all you have to do is take your original expression and replace the value of f. So in this case, we will then rewrite it as 6 plus 8 times 4. And then you'll use the order of operations to solve this. 8 times 4, you get that amount, and then you add 6 to it, and you get your final answer, which will be one of these over here, okay? And that's how you would solve that problem. Hopefully this clarified some of your some of the information you learned in the lesson. If you have further questions, you can see your parents or you can see your teacher.